Okay, fifth time's a charm on this son of a gun. All right, and I've calmed down quite a bit. All right, so just trying to, with the interruptions and with just trying to get this right, and then oh my God! All right, so anyway, and then me with technology. All right, I think we've got it now. So basically, this isn't that bad of a problem. All right, what we're doing is now there's a tension here in the string, and that's staying constant, and that tension in the string. Well, the acceleration, this tension will stay constant, but this acceleration will come down here, and I actually think down here is when the tension's, it may not stay constant because we have an acceleration that's going along here, which is changing the velocity, which is going here, which is increasing this guy also, so the tension is strongest when it's down here. I just had to think that through myself, but that's not what we're up to. Basically what we're up to, this is just a free fall problem. Right? Except that it's being slowed down because it's being held back, but still, once again, the acceleration is good old AG sine theta, like from your last test. But notice as this comes down, that angle will always be changing until it gets to the sine of 0, which is equal to 0. But that's the maximum speed right here at the bottom. So all we have to do is figure out this height here. Okay, so let's take a look at how that works. All right, so all we got to do is find that height, and at the risk of really screwing this up, I am going to scooch in a little bit, make it a little bit bigger. There we go. And then click this out. All right, so now here's what we've got. And here's how you solve this. It's basically what we're getting at is it's going to be mgh is equal to 1/2 mv squared. And you're going to solve for v, all right? Because this is a pendulum. Let's make it. Let's do it. Let's do it the legit way. Let's make this this rope. I'm going to make it 3 meters long. Okay, so there's 3 meters, and it's going to be at an angle of 20 degrees. Oh, we've got to keep it off there. So actually, what's this angle here? That angle, oh, it's 18, because look, it goes from there to there, so that's 18 degrees. All right, so let me put this here again. Put this right here. And now I'm going to draw 3 centimeters going down through that point, and you will see this is awfully thick pin to be doing this. So I come down, I'm going to go a little bit just for the pin width. What we've got to do, notice, here's where the pendulum is right now. We've got to come up with this height h here. But this L is equal to this side. This whole L over here is equal to this side. But look, you've got a right angle here, all right? So we're trying to find, because this bob's going to come right flying down through here. And this is my height h. Well, this is a right angle, correct? And here's my hypotenuse of 3. I don't know what, let's make this little L prime on the inside. So L prime is equal to, and here's my 18-degree angle right here. Here's my angle of 18 degrees, or whatever it is. Let's just call it theta. I'm just going to set this up generally. Let's just call it angle theta. Well, L is equal to big L times the cosine of theta. And H is equal to big L, because this whole thing is big L, minus L prime, which is equal to L prime is equal to L minus L cosine theta. So H is equal to, factor out the L's, 1 minus cosine theta. Okay? All right. Now, in previous videos, I probably talked way too long about how when this is at its maximum, let me show you. When it's up here, maximum acceleration. When it gets down to here, maximum speed. All right? Acceleration, again, is g sine theta, but the angle is always changing. So let's go back here. And so there you go. You've got your h. You can, all of you, no matter what your numbers are given, you can find your h, and then you just have mgh is equal to 1/2 mv squared. And notice the masses cancel. Did they give us a mass for this, Bob? Usually, if they don't give you a mass, I'm just curious if they gave us a mass for the Bob. No, they didn't. Oh, they did. But it's going to cancel. It's going to cancel anyway. So this is how you do it. All right? And that's how you find h. All right? So I was already thinking, oh, well, this is just a nice little problem like this. This is all they got to do. I forgot you had to do all this stuff in the middle. And there's a lot of physics that's going on with a pendulum. They're in physics. If you're a physics major, you do a lot of pendulum stuff up through because there's waves and, oh man, it just really builds on itself. All right, out here.